Today we're going to check points for linear inequalities. So for the first example, we're going to check if the given point is a solution to the inequality. This is an inequality because it has a less than or equal sign instead of just an equal sign. When you check the point, they're going to give you an ordered pair. Remember, this is the x, this is the y. I'm going to plug them both into the inequality to see if it is a true or a false statement. Okay, so it's 2x, where the x is, I put in the 4. Plus y, what's y? Y is 3, and I'm just seeing if this is less than or equal to 5. Okay, 2 times 4 is 8. Is 8 plus 3 less than or equal to 5? 8 plus 3 is 11. 11 is not less than or equal to 5, so check if the point is a solution. No, it is not a solution. Let's try the next one. Okay, the inequality is y is greater than negative 3x plus 4. The x is 2, the y is 1. It looks a little weird, but I'm going to plug in the y here. What is the y? The y is 1. 1 is greater than negative 3 times x. What's x? X is 2 plus 4. Okay, now I already know the left side's a 1, so I'm going to leave that alone. Let me figure out the right side. Negative 3 times 2 is negative 6 plus 4. So I'm seeing if 1 is greater than negative 6 plus 4. Negative 6 plus 4 is negative 2. Is 1 greater than negative 2? Yes. So this is a point. 2, 1 is a point to the inequality. Okay, one more. The ordered pair is x, y. So 0, 0. Y is less than. Where y is, I plug in 0. Less than negative 3/4 x. What's x? 0. Minus 5. Okay, the left side is already simplified. So I'm saying if 0 is less than 3/4 times 0, negative 3/4 times 0. Anything times 0 is just 0. So this is just going to be 0 minus 5. That's why zeros are great. So is 0 less than 0 minus 5? 0 minus 5 is negative 5. So is 0 less than negative 5? No, it's not. Okay, now we're going to look at the graph of a linear inequality, and then we're going to try to see why it's important to check points. Okay, on the graph of a linear inequality, which this is an example of, the shaded area indicates all the solutions to the inequality. So for this particular graph, which is already graphed for me, I'm going to list some solutions to the inequality. The solutions are everything in the shaded area, so all the points up here, and including the ones that go off the graph. There's an infinite number of points. You can pick anything you want. It's nice to pick something that's easy to read, although you don't have to. So for example, if I pick this point right here, that point is 2, 3. Because that's in the shaded area, that is a solution to the inequality, even though you don't know what this inequality is. How about another one? How about if we go way over to here? What is this? This is 5, 1. So 5, 1 is also a solution. Even though I don't even know what the inequality is, I already know that. Let's go on the y-axis, maybe like up here. What is that? 0, 3. So those are 3 possible answers, but there's many, many other answers. Okay, non-solutions are anything that is not in the shaded area. What's like 0, 0, not in the shaded area. If I'm trying to pick easy points, I could pick that because that's 1, 1. Let's pick one that's more interesting, maybe a negative 1. How about down here? That's negative 2, negative 3. So these are 3 possible things that are not solutions, but there's many, many more. Okay, we're going to graph this whole situation tomorrow, but for now we're just going to figure out, given a boundary line, how to check if something is a solution or not. Okay, so the boundary line of the inequality is already graphed. This line, it happens to be dashed. We'll figure out why it's dashed later. We're going to check the indicated points and shade the side of the boundary line with the correct solution point. They have marked the points for me. So they marked 0, 0, and they marked 5, 2. I'm going to check 0, 0 first, just because it's easier. That's the only reason. Okay, I'm going to plug it into the original function. This is the line that is already graphed. Okay, so if I do 2 times 0 plus 3 times 0, is that greater than 6? 2 times 0 plus 0 is greater than 6. No, 0 is not greater than 6, which means that 0, 0 should not be shaded. Do not shade the 0 side. I can already tell if it's not this side, it's probably this side, but let's check by plugging in the point. So I'm going to plug 5, 2 in now. Okay, back in the original equation. So 2 times x, 3 times y, is that greater than 6? 10 plus 6 is greater than 6 for sure. 16 is definitely greater than 6. So 5, 2, yes, this side should be shaded. So when I do the graph of this function, I want to make sure I shade this side where the point checks, which means I'm shading everything from the boundary line over. And if I had checked any point over there, it would have been yes. Okay, now realistically, once I figured out this side was no, I knew this side must be the yes side. So I don't actually have to check 2 points. I can just check 1 point, and that's enough to help me figure out which side to shade. Okay, so on this side, the boundary line is still graphed for me. This is y is greater or equal to 1/2 x minus 3. This is the line graphed already. We're going to pick 1 point that's not on the boundary line to check. And then we're going to decide which side to shade based on that. Now you can pick any point on the graph except for the points actually on the line. So I can pick this, this, this. You can pick anything you want as long as it's not touching the line. Because you have to plug it in, it's nice to pick an easier number. Okay, so in my opinion, the easiest number to plug in is 0, 0. So I'm going to plug in 0, 0. If you want to plug in something else, you can plug in something else. I'm going to show you why I like 0, 0. So this is x, y. So 0, 1/2 0 minus 3. Okay, now the reason I like 0 is because right now I have to do half times 0. If I do anything times 0, I get 0, so I don't have to really worry about the fraction. Now I'm going to see, is 0 greater or equal to 0 minus negative 3? Why, yes, it is. Okay, so where 0 is, yes, that side should be shaded. Okay, so that's telling me, yes, shade this side. So from the line up, I'm going to shade that side. If I had picked any other point on that side, I would have gotten yes. If I had picked any point on this side, I would have gotten no. Okay, that's the idea. Okay, for number 4, the line is already graphed for us until tomorrow. I can pick any point that's not touching the line. Okay, because again, I'm a little lazy. I like to pick 0, 0 whenever it's available. Okay, you don't have to pick 0, 0. There's lots of other points that are nice and easy. Okay, now if I pick 0, 0, I get y. 0 is greater or equal to 0 plus 2. So is 0 greater or equal to 0? 2? 0 is greater than 2? No, it's not. Okay, so the side with the 0, 0, do not shade that side. If you do not shade that side, you have to shade the other side. So my shading is going to be over here on the other side. And if you have a pencil, you can kind of stripe it in what you want to do. Okay, we're going to keep going. I'll try to make them a little trickier though. Okay, so y is less than or equal to negative x. They've already graphed the boundary line for me. I want to pick a point that's not on the line. Now, because I'm pretty lazy, I like to use 0, 0. But 0, 0 is touching the line. So if I get yes or no, it's not going to help me figure out which side to shade. So I have to pick a point that is not on the line. Okay, you can pick any point. You could pick 2, 0, 0, 3, 1, 1. If you like negatives, you could do negative 2, negative 1. It's up to you. What am I going to pick? I'm going to pick 1, 1. If you pick a different point, that's fine. As long as our shading matches, it does not matter which point you use to figure out the shading. Okay, so this is y. Y is less than or equal to negative x. 1 is less than or equal to negative 1? No, it's not. So the 1, 1 is not on the shaded side. So I'm going to shade the other side of the line. Okay, and if you want to stripe it, that's fine, depending on your pencil. Let's try 6. Okay, let's see. I can't use 0, 0. Darn. Okay. I could use 1, 1. That's a nice point. I don't mind 1, 1, except there's a fraction here, and I'd rather not times a fraction. Since I'm timesing the x by half, I am actually going to pick, what am I going to pick? I'm going to pick 0, comma something. How about 0, comma 2? If you pick a different point, that's fine. Just be careful. This is x, this is y. So y is greater than half of 0. Half of 0 is 0. So is 2 greater than 0? Yes, it is. So the side with the 0, 2 has solution. So yes, shade the side with the 0, 2. Okay, and again, if you pick a different point, that's okay. But our shading should match. It does not matter which point you use to determine it. Okay, last two are a little bit strange because they only have one variable. But the boundary line for negative 3 is down here. I can pick any point I want. Because 0, 0 is available, I'm going to go ahead and use 0, 0. Okay, this is x, y. Okay, y is less than negative 3. There's nowhere to plug in the x. That's okay. I can still figure this out. Is 0 less than negative 3? No, it's not. So do not shade the 0, 0. Shade the other side. Okay, one more. Okay, x is negative 3 is over here, which I can use 0, 0. Because I'm lazy, I will. So 0, 0. Remember, this is x, y. So x is greater than negative 3. There's nowhere to plug in the y. That's okay. Is 0 greater than negative 3? Yeah, it is. Okay, so yes, shade the 0, 0 side. You don't have to write yes on your graph. I use it to help remind me that I always shade the yes. Yes, these are solution side. I never shade the no. These are not solution side.